Assalamualaikum and good day everyone. I am Farra and Norais and my partner Vicgnapriya Ramesh are going to present about our recent research study, which is about mathematical modeling of assigning drivers to harvesters using the general assignment problem method to maximize the daily profit. So generally, these are all the contents that will be presented shortly. Now I'm going to start with the abstract. Through this research, we have proposed and created a methodology to solve a real-world problem, which is a special case of the generalized assignment problem. The main objective is to propose a better new method of assigning drivers with an appropriate harvester set to harvest a suitable sugarcane field to optimize daily earnings. A set of drivers have various levels of experience. Therefore, a different capability to harvest sugarcane leads to a range of daily wages. Each harvester has different operating years and engine size, which affects its fuel consumption rate and capacity to harvest sugarcane, respectively. Assigning a worker to a harvester can improve the fuel consumption and efficiency of the harvester. The mathematical model has been developed by using Excel solver. Now we're moving on to the introduction. Sugarcane is a globally important economic crop that can be used to produce both direct and indirect goods, such as sugarcane juice, molasses, syrup, ethanol, jaggery, candy, rum, and many more. But generally, most people know that the main product that sugarcane can produce is raw sugar. Raw sugar is obtained from the processing of the sugarcane juice extracted from the sugarcane stalks. The juice is clarified with lime and subsequently concentrated to produce masticutis, which is a mixture of crystals and surrounding dense dark brown liquid called molasses. The crystals, which is raw sugar, are separated from the molasses by centrifugation. Nowadays, sugarcane is harvested by mechanical harvester which move along the rows of cane, removing the leafy tops of the cane and cutting the stalk into short pieces or billets. Billets are loaded into bins which are towed alongside the harvester. When full, the bins are taken by road or tramway to the sugar mill. The field capacity of mechanical cane harvesters varies with the size. Harvesters of various brands, sizes, and varieties were later introduced to the market. Employing a specific harvester has limits, such as some fields that cannot be served by certain harvester types due to the steepness of the field or a lack of roads or tracks to the field. As a result, assigning the field to the appropriate harvester becomes more difficult. Cost control is also vital to the harvester's owner. When assigning the harvester to the field, the machine's efficiency will be considered. Many factors influence it, including the type and number of operational years, as well as the person's experience. These variations will be considered in the research study to ensure fair results. Problem statement. The problem that we discovered in this study is to match a driver with an appropriate harvester set to harvest a suitable sugarcane field to optimize daily earnings. The profit is determined by the system income and cost, whereas the income is determined by the amount of harvested sugarcane sold multiplied by the sweetness level of the harvested sugarcane. These are our research questions and objectives. Our first research question is, what is the main purpose of the study? Next, what is the impact of using generalized assignment problem method in this study? And the last one is, why do we need to optimize the driver workforce during the working time? In order to answer our research questions, we have come out with 3 research objectives. The first one is to develop a model to assign the best driver to each harvester. The second one is to optimize the driver workforce during the working time. And the last one is to maximize the daily profit of sugarcane harvesting. Now, I'm going to continue with the literature review. Through the recent research by the previous researcher, an enhanced version has been studied for the GAP to mimic the behavior of a real-world problem. The proposed challenge is the difficult-to-solve combinatorial optimization problem. To identify a promising solution, meta-heuristics and heuristics are applied. Meta-heuristics have been successfully developed to solve a variety of problems in both discrete and continuous optimization. Sugarcane is a tall perennial grass that can grow to be 3 to 4 meters tall. Cultivation is difficult and harvesting requires specialized equipment. Scheduling of fields to be harvested by harvesters is required to fulfill the goal of the farmers or harvester owner. The scheduling problem is one of the most well-known combinatorial optimization problems for all researchers. So this is our scope of research. The purpose of this study is to propose a better new method of assigning drivers with an appropriate harvester set to harvest a suitable sugarcane field to optimize daily earnings. As for the data collection, we have used a secondary data. We decided to use this method because it is less expensive and it consists wide range of information. The data collection session have taken for about 2 days to be fully completed. Model development. This is how we formulate the mathematical model according to the planning of our research proposal.
My name is Vicgnapriya Ramesh and my matrix number is 26442A. I would like to continue with a mathematical model development formulation, which is the mathematical approach, which consists steps. In the mathematical approach steps, we start from generate initial solution until discuss the results, whereas there are possibilities where implementing mathematical modeling process which have the flow where the implementation works and where it doesn't work, and continuation with that, the objective of equations. So each of the equations has its own functions, such as, for instance, equation 1 is to maximize profit from selling sugarcane, which is related to the function of the sugarcane sweetness. And whereas for equation 2, it is important that only sugarcane field K, which has been assigned harvester set J, is harvested in the process. In addition, we will continue with proposed heuristics. Based on figure 1, we first present a differential evaluation algorithm, which is DE, to solve the proposed problems in the research. And initially, DE is composed of 4 steps: generate initial solution, implement mathematical modeling process, execute the impossible process, and selection of the best constraint. Whereas modify DE as 5 steps, such as which is same with DE, which is composed with 4 steps, but additionally there is one step, which is we have to update the reserve vectors. Next is modify DE adds the following vectors. So firstly, set of second best vectors B2 vectors. The second best vector is stored while the selection process is performed in the process. Next, set of randomly selected vectors, which is RS vectors. The RS vectors is selected from the worst solution while the selection process is performed. Besides, set of vectors that are iteratively randomly generated are RV vectors. And finally, best vector given by all vectors in all previous iterations are BV vectors. Moreover, the swap heuristics is performed in the sets of BV vectors, RS vectors, and B2 vectors. The following steps are used to explain the modified differential evaluation algorithm, which is MDE. And we will continue with generating the initial solution and decoding methods, which is we will start off with initial solution, and table 1 and table 2 is consist of randomly generated target in the first iteration and time h required to drive from the parking area of harvesters set J to field K. The differential evaluation algorithm DE generally works on real numbers because the mutation and recombination processes are about to using arithmetic signs. to calculate mutant and trial vectors. Next is the decoding method. We designed our decoding method to have 5 steps. Firstly, sort all subsets of vectors separately, which is drivers, harvester, and field, in ascending order. The results of sorting are shown in table 3, which is the result of sorting value in the position of vector 1. The driver order is 4, 5, 3, 2, 1, and 6. The harvester order is 4, B, A, 6, C, and 5. And finally, the sugarcane field order is 1, 2, 3, 4, 5, and 6 respectively. And secondly, assign a driver to a harvester, and then assign the harvester to the sugarcane field using the order obeying from the step 1. And besides, we first assign the driver to the harvesters. The pair of the driver and harvester will be assigned to serve sugarcane field. The order of assignment will be executed according to the order obeying from step 1. And finally, the entity that is in the next position is allowed to be replaced when the current position violates the capacity constraints of the harvesters, which will be maximum time used in 4H. And next, for instance, when driver 4, which is in first position in driver's order, is assigned to harvester set B, the real harvester rate after the harvester is calculated from the experience factor of worker I is multiplied by standard harvesting rate of harvester J. As a result, a maximum of 75.24 rye can be harvested with the matchup. Since the harvesting field 1 cannot be done within 8.36 hours, because field 1 has an area of 80 rye to be harvested, which means it needs 8.88 hours to harvest. Field 4 is the next field that is possible to assign harvester set B, and the result is shown in the table 4, which will be the assignment process from the assignment process as well. Moreover, using Excel solver, we have been used simplex LP method, and from the method we have used, we have gained figure 2, which is time taken for the workers to complete the job using the harvester per acre of sugarcane field. And from the figure 2, we have gained figure 3, which will be the solution of the calculation. And then we will continue with figure 4, which is the hiring cost of each workers to harvester set. And from the calculation we did, we have gained figure 5 as the solution. And next, we have calculated daily earnings from amount of harvested, and from the calculation we did in the calculation, we have gained the figure 7, which is the solution as well. Besides, in this study, we used Excel Solver as a software to find the best constraint to optimize the daily earnings by minimizing the cost and time used by workers and harvesters as well. And next, as we have problem in table form, and we know the objective functions and constraints in this study, most importantly, in Excel, it is not default included. So before using this tool, we must add this software in the Excel as well. And then we implement it in Excel solver according to available data and select a suitable solving method, which is simplex LP. We also set the outcome table as binary and set the targets accordingly. Then, as for the data collection process, for this research, we have gained the data from a case study in sugarcane harvesting data set of harvesting, which is published in 2019 November. This also known as secondary data. According to the report we have referred to NDPI 2019 full report, the data for the report have been collected to assign drivers to harvesters, which will be assigned to harvesters sugarcane since it can be replaced 200 laborers to maximize daily profit. As for the sources of data, the, the data were collected from the NDPI 2019 as we have mentioned before, where the data specific to the study was gleaned from a sugarcane field as well. Then, as for the result presentation or solution, we have been used DE method to solve this research and the methods and the problems we have in this research as well. But DE is the worst heuristic for discovering a suitable solution because DE does not have a guide from the optimal option. Besides, the current goal vector has a good algorithm for finding a good solution, but it did not improve the solution quality. Finally, MDE2 compensates for MDE3 and MDE4 by displaying both diversifications and intensification behavior. Finally, MDE2 outperforms all other available algorithms in terms of finding a good solution as well. Therefore, as for the result and discussion, the outcome from the simplex LP method that we use from the Excel solver shows that the owner of the sugarcane field can assign the workers and harvester based on only three factors, which are firstly time taken for workers to complete the job using the harvester per acre for sugarcane field, secondly hiring cost of each worker to harvest set, and finally daily earnings from amount harvested. The harvester that takes only 78 minutes per acre of sugarcane field for people to finish the operation in the sugarcane field as well. And next, the total cost of hiring all harvesters assigned is 17 ringgit per hour. The daily revenues from the harvesting are 11.11 $90 per day. And finally, the objective function can be met if the sugarcane owner distributes workers depending on the arrangement of drivers we have researched in this. Harvesters and sugarcane fields shown in the figure 3, 5 and 7 that we have found before. Finally, for the solution and recommendation we have searched in this, the paper is proposed a method to solve a subset of generalized assignment problem as gap. The challenge requires assigning drivers to harvesters and then the harvesters to sugarcane fields to optimize daily profit. The drivers have varying levels of experience, implying that they have varying levels of sugarcane harvesting capability and daily compensation uh, in this daily process they have been used in the sugarcane field. The harvesters have been in use for varied amount of time, which determines their fuel consumption rate, and also the sugarcane harvesters are available in variety of sizes and capacities according to the digital era we have now. The assignment of drivers to harvesters may have an impact on harvesters' fuel consumption and hours rate since we have reduced the rates from the solver we used. We created a mathematical model and used the simple LP approach in Excel solver to solve the problems optimally. We have and then we have showed the rates that we have reduced as well. Based on the computational result, we can deduce that using alternative meta-heuristic methods with great search of mechanism,